example video for variation of parameters. For our first problem, we have y double prime minus y equals t plus 3. So our first step is to look at the associated homogeneous equation, y double prime of h minus yh equals 0. This has the characteristic equation lambda squared minus 1 equals 0, which gives us lambda equals plus or minus 1. That gives us two fundamental solutions. Y1 equals e to the t, and y2 equals e to the negative t. So this gives us a yh of c1 e to the t plus c2 e to the negative t. So now to find our yp, which is v1 y1 plus v2 y2, we need to use the following system of equations to find v1 prime and v2 prime. So v1 prime y1 plus v2 prime y2 equals 0. v1 prime y1 prime plus v2 prime y2 prime equals whatever our forcing term is. In this case, that is t plus 3. So we already have y1 and y2. We just need to find y1 prime and y2 prime. y1 prime is just e to the t, and y2 prime is negative e to the negative t. So now we can plug that into this system, and we get e to the t, v1 prime, plus e to the negative t, v2 prime, equals 0. And we get e to the t, v1 prime, minus e to the negative t, v2 prime, equals t plus 3. So we can convert this, we can solve the system any way you want. I'm going to convert this into a augmented matrix. E to the t, e to the negative t, 0, and e to the t, negative e to the negative t, and t plus 3. So now we can divide the top row and the bottom row by e to the t. So let's go ahead and do that. So we're going to take r1 and divide it by e to the t, which is the same as multiplying it by e to the negative t. That's going to give us 1 e to the negative 2t and 0. Bottom row will remain unchanged. And we're going to do the same thing to the bottom row. So top row is unchanged. And now we take r2 and subtract r1 to get rid of this 1. So we get 1 e to the negative 2t and 0, which is unchanged. And we're going to get 0 minus 2 e to the negative 2t. And we're going to get, this is going to be unchanged because we had a 0 in that column. Next, we're going to divide r2 by e to the negative 2t, which is the same as multiplying it by negative 1/2 e to the 2t. So top row is unchanged. Bottom row is 0, 1, and t plus 3 times negative 1/2 times e to the t. And now, to get rid of this e to the negative 2t, we're going to take R1 and subtract e to the 2tr2. That's going to give us, bottom row will be unchanged. And the top row will have 1, 0, and t plus 3 times 2 e to the negative t. I'm sorry, this should have been negative. And now we have v1 prime and v2 prime, so we can reconvert this back into regular terms. So now if we integrate these, we have to use integration by parts, which I will leave up to you, but v1 will equal negative 1/2 e to the negative t times t plus 3 minus 1/2 e to the negative t, and v2 will equal negative 1/2 e to the t times t plus 3 plus e to the 1/2 e to the t. So this gives us a particular solution yp, which equals v1 y1 plus v2 y2. y1 was e to the t, y2 was e to the negative t. So this gives us v1 of, we plug in v1. And y1, we plug in v2 and y2. This e to the t will cancel with the e to the negative t, and this e to the negative t will cancel with this e to the t. This leaves us with negative 1/2 t plus 3 minus 1/2 minus 1/2 t plus 3 plus 1/2. The plus 1/2 will cancel with the minus 1/2, and these two negative 1/2s will give us a negative whole, negative t plus 3. So that's our particular solution. So our y of t, which equals the homogeneous solution plus our particular solution, is going to be c1 e to the t plus c2 e to the negative t minus t minus 3.